All right, so it's Thanksgiving week, and I'm going to answer your question about summary 3 and the negative coefficient on the quadratic term. But I'm also going to just take you through some of the things we've got going for the program. We've got our industry panel coming up in a couple weeks, and I'll just show you some of the contacts that we currently have in renewable energy, and walk through that. So pull up Windows Journal. All right, so summary 3. Here's 3 things to consider. So for a linear system, there's a few different ways the system can behave. So I'll just draw three different scenarios. So the line can go up, it can go down, or it can be flat. Those are the only 3 things it can do, right? So in this case, the slope is positive. In this case, the slope is negative, and in this case, the slope equals 0. And those are really the only 3 things it can do. Now, it can also, now given that the curve has what's called 2 degrees of freedom. So it can rotate, meaning that it can be more positive or 0 or negative. So as m changes, it rotates, or it can move up and down. Now you might say, well, can it move right to left? Yeah, but that's the same as moving up and down. So if it moves right, it moved down. If it moved up, it moved left. It's just the line, right? So M controls that knob, if you will, and B controls that knob. Pretty simple. Those are the 2 knobs on a linear function. Okay. Exponential. Now, let's see here. Exponential. So the exponential function can never truly be flat, but it can do a couple of things. It can sort of be in a runaway scenario, or it can approach something that looks more like this. And well, I guess there's a couple other things it can do too. It can do this. And what's the last one? So it can curve, or it could do this. I mean, those are like the 4 different curves you can have. So you can sort of spiral up and out of control. You can sort of decay into some steady state. You can reach some sort of stability, or you can crash and burn. So this is actually this is an exponential with, and if you have E equals a to the E negative tau t. So actually let's do it this way. It's easier to think about it this way. E to the tau t. So if tau is positive, the thing just keeps getting bigger and bigger forever, right? If tau is negative, it can sort of softly land into a smooth landing. These 2 curves are actually logarithms, which are just the opposite of or the inverse, if you will, of an exponential. So in a logarithmic, it can sort of grow steadily and steadily forever, or you could just take the negative of it, but it crashes and burns. So again, this thing right here affects the shape. So what if tau were equal to 0? You just have a line, right? Because anything to the 0th power is 1. It would just be a flat line. So somewhere in between, so tau affects the curvature of the exponent, and A just basically makes it, you know, go up or down, get bigger or smaller. So that's the exponential model. The quadratic, now if you remember, in a circle, any 3 points are always going to uniquely define a circle. I kind of missed that top one, but you can see you can't draw a second circle through those 3 points. There's only one. Unless you like draw the points really big, then you could put a couple more, like the trick where you know, anyway. So the 3 things that happen with the quadratic, and the most, let's just kind of ignore b for the time being, but we know that we have y equals ax squared plus bx plus c. So the quadratic can go like this. It can also go like this. So in this case, a is positive, the thing curves up, and in this case, a is negative. The thing curves down. The second derivative is negative and curves down. So that, Robert, I think answers the negative. So if you have 3 points, and let's say here's your first point, here's your second point. Now if you go ahead and say, hey, I see my line, if my next point is above the line, a is positive. If the next point is below the line, a is negative. If a were 0, it's just a line, right? So that's the beauty, right? So if a is positive, it's heading up here. If a is negative, it's heading down here. If a is 0, it's just a line, and you revert back to the linear form. Pretty straightforward, right?
When I change the trend line to polynomial, it turns negative.
Yeah, it will, because you're showing Excel the 3 points, and just like drawing that circle through the 3 points, it's going to draw a parabolic line through it, quadratic line. And then, so with, let's see here, so B. So the B's a little more complicated, but anyway, it's going to affect the shape. So if B is more positive, it's going to look more like this. If B is more negative, it'll kind of just it won't be as curvy. It will affect the curvature. So this is B positive. This is B negative because A is always going to dominate the shape, and then of course C, just like with the linear form. Well, if we have our line here, basically you're just looking at the initial point. So if the initial point is here, this is C positive, and if the initial point is down here, this is just C is negative. So it just tells the function where to start. Because when x equals 0, when those two are 0, it just says, okay, where does this thing cross the ordinate? Yeah?
Where are the videos that you have posted for how to create these graphs?
Oh, sure. Okay, yes. The question is, where are these videos? Show you.
They were pretty easy to follow, but that first one does have a video. So your commentary, there's no way.
Nuclear radiation's going to kill you.
This problem is not about nuclear radiation.
Oh, sorry. I think, what's happened, I don't know where.
It was on the world meter set, I think.
Oh, really?
The world
Okay.
meter at
The
the
world
bottom, I
meter
think,
was, I must have
video.
clicked something and it
Yeah.
just was running in the background.
It was the YouTube.
Well, what's funny is
Oh,
because it's not, the audio doesn't come through the speakers, but it's still streaming through the
Yeah,
computer.
it's muted on your computer, but yeah.
That's, well, anyway.
It's still pretty easy to follow. with
Okay.
your commentary.
I've had,
They just have the filter.
I've had my videos censored before because I had like Foo Fighters going or something, or like Crosby, Stills, and Nash in the background, and like seriously, they'll troll for that and say you can't play our music behind your videos without.
Wow.
That's
Yeah,
crazy.
it happens. Yeah.
Infringement.
Yeah.
Ridiculous.
Well, I don't know. I went out to a website looking for. I was just looking for myself online, and I went to some site. I was going to have to pay $20 to see my own solutions that I wrote at Drexel University 10 years ago.
Wow.
That's hilarious.
Someone had, copied them. I mean, I had them up there, for my students to see, but someone had copied them, put them behind some pay-per-view firewall. I'm like, well, I don't remember signing a royalty
Yeah, where's my money?
agreement for you guys.
Could actually make money off it.
Well,
Oh,
well, like we said in chapter 12, everything's for sale, right? Okay, so the question is, where are the, so here's a few.
Oh, okay.
Lecture 19,
Oh, I see.
another one, summary 3, here's another summary 3, how-to, so there's a few of them out there.
Mhm.
I think they're pretty well labeled.
Yeah, the ones above that are most recent, but.
Yeah. And I think I gave them a little more too, so. I think this would have been, well, actually, this was from a previous year, so, yeah. Still relevant, though, it's the same summary 3. Okay, and I think we wrapped up problem set 2 last time. So there are really only 2 chapters left. So we're gonna go through penalties, and then we're gonna go through remedies, and we'll do that in the final 2 weeks. So
Penalties for polluters?
penalties for polluters, yeah.
That video.
Yeah, and we're facing some of that right now. One of the coolest things I saw recently, I'll just show you this little slide. I've been working like crazy on this PowerPoint. Give you the spoiler. This is my weekend. I'm not going to show it all to you, but yeah, so check out this. If you zoom in on this solar farm here, in the bottom right, this is one of my business partners helped install this farm in California. And if you look really closely, they built the solar farm on a landfill.
Nice.
So, otherwise kind of yucky land, what are you going to do with it?
Yeah, that's really good.
Pretty good use
And
of,
then we cut that sun back so it's not producing so much methane too,
yeah,
right?
yeah. Well,
Well, they did.
it's a good question. Yeah, if you keep the landfill cooler, does less methane come out? Probably. There's probably a sweet spot for methane production. So, all right. So I'm just going to
That's crazy, that's cool.
put a little fork in that one, and then yeah, let's just dig into the industry panel a little.